Hey guys, welcome back to ECE 2100. Today, we're going to be covering Lab 6. So, if we can come take a look down at our circuit here, we've got our circuit 1 built. And what we're going to be doing is, if you can zoom in on our equipment here, we have our function generator here, and we've got it set to 5 kilohertz with an amplitude of 5 volts peak to peak. You will be sweeping through a variety of frequencies for this lab. So this is just a test startup frequency. Over here, we have our configuration to go from the output of the function generator into the circuit here and to the oscilloscope up there. So now we're going to connect up our positive to this resistor and the negative to this capacitor. Again, it doesn't matter which one's positive and negative since you're in AC, it doesn't really matter. So now we're going to go ahead and then connect up our oscilloscope. So this is the positive and negatives of our oscilloscope. We'll connect up the positive right here on this capacitor and the negative right here on this capacitor as well. And so now you can see we have a signal being output by the circuit. So what this circuit is this will be either a high or a low pass filter. I'm not going to tell you which. You'll have to discover that experimentally. Between circuit 1 and circuit 2, one will be high pass, one will be low pass. So taking a look at this circuit, we're going to see that as we change the frequency, the voltage across the capacitor will change. One of the ways we can do that is by looking at the oscilloscope. So you'll see that as I increase the frequency, the output in green shrinks. As I decrease the frequency, the output in green grows. So you can see, because of that, we know that it is either a high pass or a low pass filter. What I will tell you is that a high pass filter filters out low frequencies, and a low pass filter filters out high frequencies. So you can make interpolations from there. So another thing that we're going to need to be doing for this lab is we need to find the decibels of this circuit, and we can use the multimeter to do that. So what I'm going to go ahead and do is I'm going to attach the two leads of the multimeter to the positive and negative inputs of the circuit. We're then looking at AC voltage. You can see we're getting 1.7 volts AC. So what we're going to do is you're going to press the null button to zero it. Then you're going to press Shift dB, or the null button again. And so then I'm going to move this positive right here over to the same as the capacitor. And now you will see we're getting a reading of negative 9.9 decibels for this. What you'll watch is that this is directly proportional to the output voltage, because as we increase the frequency, you'll see the output voltage drops and the decibels increase. Sorry, not directly proportional. But it will be proportional. And so you can see as we decrease it, the decibels go towards 0. And then as we increase the frequency again, it's going to increase the decibels. All right, so now moving on to circuit 3. So circuit 3, we're going to have a resistor, a capacitor, and an inductor. So this is going to be an RLC circuit. So you would have to use RLC analysis in order to properly analyze it. So what we're going to go ahead and do is we're going to go ahead and connect the input and the output, not the input and the output, the positive and negative inputs, and then we're going to connect the oscilloscope across the capacitor and the inductor, and we're going to connect the multimeter at the same points. So what we'll see, if we auto-scale this quickly, is we'll see, again, something pretty similar. There's not much of a phase shift at 31 kilohertz, but as we decrease frequency, if we go horizontal, you'll see there's starting to become a phase shift. Right here, especially, you can start to see that phase shift. And you can see that it peaks in its notch. So this circuit is going to be a notch filter. So you can see right here, it's starting to notch, and it's getting rid of the output voltage at around, in our case, this circuit's gonna be different, somewhere between like 7 to 9 kilohertz. So now what we're going to be able to do is we're going to, again, take our decibel reading. So the way we're going to do this, we're going to hook it up to the input. We're going to press the null button. We're going to press the shift dB. So now we're at 0 decibels. We're then going to change our positive over to where we're measuring across. And you'll see that right now we're about -9 decibels. So you see that as we decrease it, we'll be at like 0.7 decibels. As we increase the frequency again past that point, we're at about -0.8. But once we hit that point, you'll see we're at about -9. So we know that there is a notch frequency somewhere in here. You're actually able to calculate that using the equations that will be given to you. When you calculate that, you want to test around that using a bunch of different frequencies until you find that notch. And at that point, you can then create a graph to then display that notch. All right, well, thank you very much. That is going to be all for Lab 6, and good luck.